Hello everyone. Is my voice audible? Please, can someone
Yeah, it's audible.
It's audible. It's audible.
welcome everyone? Thank you for joining us for today's workshop. My name is Anirudh, and today I will be your moderator. So, without wasting further time, I will present our today's speaker, Shreehari Kulkarni. He will be going through the JavaScript workshop. Over to you, Shreehari.
Anirudh, your voice cut off. Couldn't hear it.
As hope I am audible to all of you.
Yes, sir.
As just now Aniruddha Budi introduced the today's speaker. Mr. Shreehari is studying in fourth semester of Information Science and Engineering. Very enthusiastic programmer. Uh, he came forward to give a lecture on JavaScript and basics. Today, hope all of you will learn something out of this workshop. And I now ask Shreehari to go ahead with the workshop. Thank you.
Thank you so
On
much.
behalf of on behalf of whole ACM student chapter, I would like to thank Shreehari Kulkarni for organizing this workshop. So let's get started.
It's my pleasure. Thank you so much. Hello, everyone. My name is Shreehari Kulkarni. I'm from fourth semester Information Science and Engineering department, and today my job is to pique your interest in JavaScript. So let's get started. Can somebody confirm? Is my screen visible?
Not yet.
No. One sec. Now.
Yeah, it's visible now. It's visible.
Okay. So let's get started, guys. So JavaScript is the most used programming language currently in the world. This is our agenda for today. We'll be covering all of these things. As far as the DOM API is concerned, we'll be covering that only in the project section. We'll start with the projects at 1 p.m. exact time. If there are some concepts remaining after 1 p.m., then we'll cover those after the projects. Let's see how JavaScript was first made. The process of waiting for backend to validate the user data was tedious. So basically, when user had input a password, say he input just 3 characters of password, the minimum requirement for the password was to be of length 6 or 8 or 10. So this data was first sent to the backend. The backend used to validate this and then send an error saying the password is too short. So this was very tedious. So there was a need of a programming language that could validate the user input before transferring the data to the backend. So in September 1995, the most famous browser at that time was called Netscape Navigator. One of their programmers called Brandon Ike developed a new scripting language in just 10 days. It was originally called Mocha but quickly became known as LiveScript and later on JavaScript. In 1997, due to the rapid growth of JavaScript, it became clear that the language would need to be properly maintained and managed. Therefore, Netscape handed the job of creating a language specification to European Computer Manufacturers Association, ECMA. It's also now known as ECMAScript, and they standardize the syntax of JavaScript. So where is JavaScript used? Until 2009, JavaScript was used only for creating web pages, to add dynamic behavior to a web page, and to add special effects, form validation, etc. In 2009, a programmer named Ryan Dahl took Chrome's V8 engine and wrapped it inside a C++ environment. This allowed JavaScript to be executed without a browser. So now JavaScript is used in the front end, back end, games, embedded systems everywhere. Because of the features of Node.js and the web, JavaScript is now the most used language in the world. So programming with JavaScript. I'm assuming everybody in the meeting currently is aware of one of the programming language. It could be C, C++, or Java. JavaScript supports object-oriented approach as well as functional approach. So that's enough theory. Let's start coding. So first of all, we'll see how JavaScript can outputs a statement to the console. So let's create an app. JavaScript file should end with the extension of .js. I'll be using Node.js to execute JavaScript, but you can do the same thing in a Chrome browser. So basically open a new tab, right click, inspect, and then go to console, and whatever I write here in the VS Code, you can directly write it over here and you'll get the same outputs. So first of all, let's see how to get an output. To do that, we write console.log and we pass in a string. Executing this will get us our output string. The same goes for console.dir. So we get hello world over here as well as hello world over here. The difference between these two is that console.log calls the toString method of the passed in object, whereas console.dir just outputs the object as it is. That's JavaScript consoles logging the output. Next, we'll look at the declaration of variables. In JavaScript, there are no fixed data types. Like how we write int a is equals to 10 in C or C++, we can't do that here. There are three methods of declaring a variable. The first one is var a is equals to 10, or we can write let b is equals to 10, or we can write const c is equals to 10. These are the only three methods to declare a variable. We'll look at the differences between all these three. Just remember that for var and let, there is no need to initialize the variables, whereas for const, we have to initialize the variables. So let's look at the differences between all of these three. Let's say the var a is equals to 10 in the outermost scope. And then let's make a block over here and change a is equals to 20. Coming out of the scope, let's log the value of a. This will be changed to 20. So basically, var is scoped to its outermost function. Assume the whole file is in a main function. If we change this to let a is equals to 10, and then let's make it let a is equals to 20 over here, we still get the outermost scoped value. So basically, let is scoped to its parent block. It's called as lexical scoping. So a is 20 only within this block. Otherwise, it's 10 outside the block. And for const, it follows the same rules as let, except that it cannot be modified. It's immutable. Let's look at the initialization of variables. We did look into this. I just now initialized all three variables. So the basic data types in JavaScript, we have a number. So let a is equals to 10. Console.log type of a. This will give us a number. The next, just a side note, if we try to convert this, convert a string into a number, let's say number.parseInt, and pass in a string that is not a number, it will give us a data type called as NaN. This is an object and is abbreviation of not a number, just as a side note. The next data type is a string. Now the type of A will be string. The strings can be either single quoted, we can wrap them with double quotes, or there are template strings. We write them using backticks. And one more thing that's interesting about template strings is that we can add JavaScript code inside the string. So we can write hello $, curly braces, name, and let's say name name is equals to Shri, and we have to output this. So console.log. So we get hello Shri as the output. These are the basic data types. We'll be looking into objects later on. Booleans are true and false. Undefined is a data type that is, we have initialized a variable, but we have not defined it. We have not initialized a value yet. So this is initialization. If we remove this part and just log a, we get undefined as the output. A variable can change its type dynamically based on the value assigned to it. So if we have a is equals to a number, let's say 10, we can later on change it to a string. This is completely valid in JavaScript. It's a weakly typed language. This is an interesting trivial question. Can anyone in the YouTube chat section write or type banana without actually typing banana? Just a second, I'll open the chat as well. Anybody in the chat? There are no responses, so let me just go ahead with that. Okay, no. To do that, we have to first make a variable, let's say output or result is equals to, we'll type the first two letters BA, and then we'll concatenate it with number.parseInt, and then pass in a string value, anything that's not a number, and then finally add a to the end. So this parseInt will give us NaN, so BANANA. So that's what we get as the output. There we go. If we want the uppercase, then we can do 2 uppercase. And we'll get the final result as banana. Moving on. Did somebody say something? Okay, somebody had an answer, I guess. Sorry, I couldn't see that. Moving on, the comments in JavaScript. You can write a single line comment by prefixing the line with double slashes. This is a comment. Or you can type multiple line comment using /* and ending with a */. Moving on from comments, we have operators in JavaScript. This is where I said you guys should be knowing C or C++. It's exactly the same like C or C++, where we can add, subtract, multiply, raise to divide, mod, increment or decrement. I'll show an example with one of those. So 10 plus 20 is 30, 10 mod 20 is 10, and so on. All the operators remain the same as they were in C or C++. The assignment operators, they still remain the same. Say let A is equals to 10, B is equals to 20. Let's say we want to add B to A, we can do A is equals to A plus B, or in short, we can write A plus equals to B. And this will give us 50. Now we can remove this. We will get 30 as the answer. Moving on from assignment operators, there are some more operators like logical and, logical or, and or not, etc. Bitwise operators. Everything remains the same as it was in C and C++. The conditional statements, again the same. If something is true, true block, else we execute the false block. Since the expression here given is true, we get the true, and if the expression was false or falsy values, then we get false as the output. Switch statements can switch between multiple cases. This is useful when we have multiple if-else conditions. So let's say switch 10, we'll have a case 10, break, and we'll have a default case. And in case 10, let's log 10. So since the switch case is given 10, the parameter provided in here, we can log 10 to the console. But if no cases match, if we put 11 here, we'll get the default output. That is no matches. If we did not provide the break statement over here, we'll get all three of them continuously since there is no break in between each one of those. Actually, it should be 10. We'll get 10, 11 and no matches. So this remains as it was in C or C++. Moving on from switch statements, we have loops. Loops are a little different than C and C++. So let's say loops are first of all used to repeat or iterate over a block of code multiple times with or without the same values. So let's say we want to output hello world 10 times to the console output. So we write for let I is equals to 0, I is less than 10 plus plus I. We log hello world, and this will log hello world 10 times to the console. We use for loops when we know how many times we have to loop before the loop itself. Otherwise, we use a while loop. A while loop will take a statement such as, let's say, let a is equals to 0 and let b is equals to 5. Do the loop until a becomes b. So while a is not equals to b, let's loop and log hello world. And then we also have to increment a each time. So this will log hello world 5 times. There it is. There is another kind of for loop in which we can directly go through an iterable. I'll explain what arrays are later on, but for now, for an example, let's write an array. We can iterate through this either using indices or using this for loop. These for loops are called for of loops. For let item of a, we will log item. So we get all the items directly from the array using the for loop. After loops, we have something called as the hoisting. So basically, what hoisting means is that we can use a variable even before its declaration. Let's say log a and then declare a, where a is equals to 10. The where a part will be hoisted on top of the scope. So basically where a is available before the console log. So this will not give us an error. Instead, it gives us undefined because only the declaration part is hoisted, not the initialization part. So basically after compilation, where a goes over here and a becomes 10 down here. And if we completely remove the declaration, we get a reference error that a is not defined. That's hoisting. Basically, the variables are moved to the top of the scope by the JavaScript interpreter. There are two types of equality operators, double equals and triple equals. Let me show you what they do. So let a is equals to 10 and let b is equals to the string 10. So now if a is double equals to b, a normal equality operator, let's log a and b are equal. So this to a normal programmer would seem bizarre because a string and a number cannot be equal. But what the double equality operator does is that it ignores the data type and just compares the values. So this will actually be true in JavaScript. Since this became an issue, they added the strict equality operator, or rather the triple equals, and this compares the data type as well as the values. Now they are no longer equal, so it will actually go to the else part. And A or B are not equal. So we get A and B are not equal. That's the strict equality operator. The strict equality operator is more secure than the normal equality operator. Let's look into arrays. Arrays are used to store multiple values in a single variable. I'll show you the declaration of arrays. So let's first see why there is a need to use an array. We have to write multiple variable names to store multiple values currently. So we can do this if the number of variables is less. But what happens when we want to store 1,000 values or 1,000,000 values? In that case, we have to use an array. An array can be declared like this. Let A is equals to new array and pass in the values. A, comma. So this is an array. If we log A, we get the array as the output. But this is a bit tedious to declare a new object and then writing the array. So we basically write an array literal where we pass the object directly. This is the easier way to write the array. So we initialize an array using square brackets and then pass in the objects that we have to store in the array. And now to access the elements in the array, we use zero-based indexing. So A of 0 will give us A of 1 will give us B, and A of 2 will give us C. There are some properties with respect to arrays. Let's find out what are they. If we write a.length, we get 3 because there are 3 elements here. If we had numbers in the array, unsorted numbers, if we want to sort them, we write a.sort, and this will sort the array in place. It will not make a copy, rather it will just sort it as it is in its own scoped reference. So that will sort the array and give us the output. The next one will be a.push. Push is used to add an element to the end of the array. So basically after 1 in this case. So if we write a.push, let's say 10, we'll get 10 as the last element. A.pop will remove the last element. So if you write a.pop, it will remove the last element. The last element in this case was 10 because we pushed it, and then now it will pop it off. So we'll get the original array as the output. Like this. Next one is index of. This will return the first appearing index of a particular value. So if you write a.index of, let's say index of 5. 5 is first appearing at position 1. So it gives us the output of 1. We have last index of. Basically, if there are multiple values, then we can use last index of to get the last time that value is appearing. Then we have unshift and shift. Unshift is used to add an element to the front of the list, and shift is used to remove an element from the list. From the front of the list. So a.unshift, let's say 10, and then log A. So 10 is added to the front of the list. Now if we unshift, shift, then 10 will be popped off from the front of the list and we'll get the original array as the output. That's all. These are the most important properties and methods with respect to the array. Let's move on to objects. But before moving on to objects, let me show you something. I declared this array with the keyword let. I'll be using const over here. Okay. So we all know that const is basically when we want to make a value immutable. But in this case, if we write a of 0 is equals to some other value, let's say 10, and then log A, you see that the variable has changed even though the reference is constant type. We'll look at how to solve this in the objects section. So what are objects? Object is a data type that contains key value pairs. There are multiple ways to define an object again. Let's look at those. So let object is equals to new object. We call the constructor of the object class, and then let's add properties. So object dot name is equals to string, and then we can log the object. So this has given the output as we have added a new property and we have given it a value. But this is again becoming tedious, so we can use object literals. Basically open and close a curly brace, add a property name, and give its value. Name is Shreehari. Now again, if we change this to const, we can still manipulate the properties. You can see that it's changing from Shreehari to Kulkarni. What if we want to stop this? To do that, we have to write object dot freeze, then passing the object that we want to make const. If we do that, we can no longer change the values. The name remains Shreehari even though we are trying to change it over here. This does not give an error, but it does not manipulate it either. So in some cases, we want to allow the manipulation of names, but we don't want the user to add more properties. In that case, we use a method called object.seal. Now, if we try to add a new property, let's say last name, then it does not allow the last name property to be added to the object. So object.seal just packs the properties. It does not allow more properties to be added to the object, but it does allow the pre-existing properties to be manipulated. So we can change the name over here like this. The same goes for array, by the way. We just write, if this was the array, just have to write object.freeze. This will not allow the array to be manipulated any further, and this will be the final output of output of our console log. Moving on from objects, I think that's all. Another thing, we can also have functions as as values of our object properties. I'll show you how to define functions later on. We looked at the solution of this, how to make an object constant. Now let's look at spread operator. So let's say we have an array and we have another array. Okay. Or rather, a more simpler example would be let b is equals to a. So we are copying all the elements of b into a into b. So if we log a and then log b, we'll get the same outputs 1, 2, 3, 4, and 5. But if we change a value in b, you see that it also reflects in a. This is because this is a soft copy, not a deep copy. To do a deep copy, the normal method would be we declare b as an array and then we use a for loop. B dot push the item. And now if we manipulate b of 0, it will only be reflected in the b array. But this becomes a bit tedious. JavaScript made it even more simpler to copy arrays. We can do that with the help of the spread operator. To do that, we just type 3 dots and then a. This will spread all the elements of a into b, and b is again an array. So this will basically deep copy a into b. The spread operator also works with objects. Okay, so now I have an object with two properties, and now we'll transfer these two properties or deep copy them into another object. So that's it. We completely copied the object A into B by using the spread operator. There we have it. After the spread operator, let's look into functions. A function is a block of reusable code which can be called anywhere in your program. This eliminates the need of writing the same code over and over again. It helps programmers to write modular programs. So basically, we define different modules for the programmers to call the functions, which do the same thing, but it reduces code, it increases code reusability. So let's look at how to define a function. There are multiple ways, but the most common way used is to use the function keyword and give the function a name. And then parenthesis, we can pass any parameters over here. Let's say the function was great. And then it takes in a name. And to return a value, we use the return keyword. Let's use template strings. There. And now to call the function, we have to use greet with parenthesis and we'll give our input over here. Since we are returning a string, we have to log it to the console. Now we get hello Shreehari. The Shreehari was the argument that's received in the parameter over here, and we return from the function. This is the first way to define a function. The next way is to use a named function like let greet is equals to an anonymous function. Anonymous functions are basically nameless functions. We are assigning a name later on. The pros of this method are basically you can scope the functions, lexical scoping, functional scoping. So this can also receive a name and let it return the same thing. So this will work exactly like the function above. We'll get the same output. The third type and the most interesting type probably is the fat arrow function or just the arrow function. So we'll write let greet is equals to parenthesis equals to and greater than, and then open and close the curly braces and return the name. Since we are using a parameter over here, we'll have to pass it. So this is the same as the above function. This is also an anonymous function. We are giving it a name over here with a scoping, and I'll also show why this is the most used type of a function. R is not defined. Sorry, I had highlighted a certain part of the code. So this also gives us the same output. The most interesting part about this function is that even if you remove, when there is only one parameter being passed, you can just remove the parenthesis. And if there is only one statement that is being returned, then you can also remove the curly braces. This will also work the same as before. So this gives us the same output. This is probably the most used type of function declaration. The next one is the REST operator. So let's say we have a function called add, which takes in two parameters A and B, and it returns, let's say, return A plus B. So now we are expecting it to add 10 and 20, which it does fine. What if we add 30 over here now? It does not take in the third parameter at all. To fix this, we can give an indefinite number of arguments over here and we can get the solution. We have to use the REST operator for that. That is dot 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 and then A. So basically a REST operator looks the same as a spread operator, but can be only used as the last parameter of a function. The REST operator does the opposite of what a spread operator does. It groups multiple objects into an array. The REST parameter syntax allows a function to accept an indefinite number of arguments in an array. So dot 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 A will basically convert these three values into an array, and then we can return the final result like this. let result is equals to 0. Let's map through this. A dot map will get each item and we'll add them to the result. Result plus equals item. After all of this, we have the final solution in the result variable, so we can just return the value. So now if we add 10 plus 20 plus 30, we get 60 as our answer. We can also add more values over here. We get the solution. We can add an indefinite number of arguments. That's all about the rest operator. Next, an interesting thing, a set timeout. This is a function that is used to do something at a later point of time. So let's say I want to set timeout and log hello after 5 seconds. And we pass the number of milliseconds. So 5000 milliseconds is 5 seconds. When I run this, it will wait for 5 seconds and then console log this. Hello after 5 seconds. And let's log A, B, and let's change this to C. A, B, and finally C. Let's actually do a little change, do some changes. Let's console log A in the set timeout function, B outside and C outside. What would you think would happen if the set timeout was reduced to 1000 seconds, milliseconds? We get B, C, and A. What do you think happens if there is no set timeout? That any guesses? Okay, one of the answers is normal, and one of the answers is A, B, and C. This would be a normal human intuitive behavior, but the answer is not A, B, C. We get B, C, and A. Why is this the output? For that, we have to know what JavaScript event loop is. So basically, all the function calls are put onto a stack. That is console.log B and console.log C. All of them are put on the stack. And set timeout is a web API function. Web API functions are not put on the normal JavaScript stack. They are put on the web API heap. So basically, let's start from this slide. So phi is put over here and phi is removed. It's just printed out directly. Same goes for 6 as well. But then when it comes to set timeout, basically the first function call, it is not put in the call stack. It's rather put in the web API. So when 5 and 6, so basically 5 is put here, 5 is popped off and console logged. 6 is put in, 6 is also popped off and console logged. After everything is executed, then the web APIs will call their callback functions. The callback functions in this case would be, this is the callback function. This anonymous function over here is the callback function. So after the call stack is emptied, then the web API callbacks are called and then we get the console log output. It doesn't matter if the timeout is 0 seconds or if it's 10 seconds, 100 seconds or whatever. So that is why we get B, C, and A regardless of what the delay is given. Next, we'll look into asynchronous JavaScript. We'll come back to this part because I want to do the projects first and then we'll look into asynchronous JavaScript. So I want all of you to code along with me if that's possible. Create a new file. Let's we have 3 projects: counter, stopwatch, and I think someone said repeat that. Okay, let me repeat that. So basically, console log B, console log C, and console log A. We have 3 console logs. The parser will first come across set timeout function. This function is not a regular JavaScript function. This is a web API. The web APIs are handled by the browser, not by the JavaScript engine. Okay, no coding along, no, fine. Okay. So set timeout function is not passed on to the call stack. It is instead passed on to the web API section of the browser. In the web API section, it executes. If there is a delay, it waits for it, and then it pushes the function into the callback queue. This is actually happening instantly because there is no delay. So this callback function is directly being pushed into the callback queue over here. But this callback queue will not pop off any element unless the call stack has been emptied. But the call stack is not empty because once the set timeout function has been pushed to the web API part, uh, we'll get two more functions, and those two functions will be on the call stack already. So console log 5 will be executed first, and while it is being console log B will be executed first. While it is being executed, already the callback function for A is sitting over here. So B will be executed, then C will be executed, and finally this queue will be emptied, and the callback function will be pushed over here, and that will execute A. That's why we get the output as B, C, and then A. I hope that's clear. Okay, fine, nice. Let's start with the projects. Let's do the counter first. This is the part of the workshop that is related with the DOM API. So let's first look at what a DOM is. Let's create a file. This is just boilerplate code. Okay, now you can see some tags over here, HTML, head, and the body. So basically the DOM is this. It has a tree-like data structure, and we have HTML tag over here. And then we have a child element, that is the head. Then we have another child element, that is the body. This is how the actual structure is defined in the memory behind the scenes. So what the DOM API does is that it allows the user, or the programmer rather, to access these elements and to manipulate these elements. So we can access the body, add some more things to it, remove some things from it, and etc. So let's look at an example with a project. So this, in this example, we'll be creating a counter. A counter is basically how in Flipkart or Amazon you add or remove items. Okay, so we have to link a JavaScript file to this. So let's just create one, index.js. And then we have to link this index.js to our HTML file. To link, we use the script tag, and then source equals to index.js, and close the script tag. We use two more parameters over here, async and differ. So what async and differ does exactly? Let's assume red color is our HTML file. So the HTML file is currently loading, and then it comes across this script tag over here. When it comes to the script tag, let's assume blue is our script tag. Script tabs or script files can be very huge in number, in size. So it might take a while to load them. And then it continues loading the HTML. This can take a lot of time. So we use the async keyword over here. What this does is that it keeps on loading the HTML file, but whenever it incurs the script tag, it puts that script tag onto another thread. This will load it alongside HTML, and whenever the loading is completed, it will rejoin that. But this again is will give us problems, since JavaScript files might actually be accessing something that's going to be loaded in the future in the HTML. So to avoid this as well, we use the defer tag. What this basically does is, once the HTML is completely loaded, only then this will attach the JavaScript file to the HTML file. That's why we use async and defer in the script tag. So let's get coding. I am using an extension called live server. This will basically refresh on its own whenever there are some changes. So to get the body from the index HTML, so this tag will not be actually writing anything here. We'll be manipulating this HTML file using the DOM API. So to get the body tag out of there, we'll say const body is equals to document dot body. Now we have a reference to this tag and we can do anything with that tag. And now we want to create a element inside over here. To do that, let's say const h1 is, by the way, these are just variable names. You can have them as anything. I'm just using the normal tag names. So h1 is equals to document dot create element. The element we want is an h1. Okay, the default value of h1 should be 0. So h1 dot inner HTML should be 0. Okay, now we have created the h1 and we have a reference to the body. This has not yet worked because we have not inserted the h1 into the body yet. To insert the body h1, sorry, we have to do body dot append child h1. After we do that, we'll get a 0 on our HTML web page. Now to code the increment or decrement parts, let's create two more elements. We'll be creating a button and we'll be creating a minus button. Okay, so both of these are normal HTML buttons, but we have not yet added the logic. We'll also have a variable called let to maintain the state, maintain the current state of the value that has been that is being displayed. And now we'll have the logic to increment or decrement this value based on the user input. So we can we also need to add these buttons, and we also need to give some names to the buttons. So plus dot inner HTML is equals to increment and minus dot inner HTML is decrement. We'll add event listeners. Events are basically something that happens to the HTML tags. Anything that happens to the HTML tag. We handle these events in the following way. We'll say plus dot add event listener. The event is click. So whenever the user clicks on this particular button, the increment button, we'll append the childs later on. We have to increment the value of the state value. So let's increment it. So plus plus value. And then we'll also have to update the value on the HTML page. So h1 dot value. So h1 dot inner HTML is value. We'll do this, apply the same logic to the decrement. So minus dot add event listener click. We have to decrement the value instead of incrementing it, and then update the value again. Now everything is done. We just have to append these elements to the HTML file. So it's 0 currently. We'll append plus and we'll append minus. On increment, this will go on incrementing, and on decrement, this will start decrementing. The most important part about the DOM API is, or basically the most important application would be to dynamically add or remove feed from your Instagram pages. That would be a perfect example. So this is our first project wherein we have created a counter and we can increment or decrement the values here. Let's look at another example, the stopwatch. I'll share this code later on through GitHub in the WhatsApp group. Let's create a stopwatch. Now I've created a stopwatch index.html. Again, we'll write some boilerplate code and also attach the script tag. We'll create the JavaScript file. And And this time, let's not just use the JavaScript file, let's also use the body tag actually. Okay, so we want to display the timer, we want a start and stop button, and we want a reset button. So let's have an each one. This will by default show 00. Let's give it an ID to get a reference later on. Let the ID be display. We need a button with the ID. Let the ID be start stop. And by default, this button should display start. And finally, we'll have a reset button. Okay, so now we have the basic parts over here. Let's restart this server. We have a start button, we have a reset button, and we have the stopwatch timer. Let's get coding the logic for the stopwatch. So basically the logic is that we have to increment seconds with a set interval, and then after each interval we'll be checking if seconds has reached 60. If it has, then we'll increment the minutes. The same goes for hours as well. So let seconds equals to 0, let minutes is equals to 0, and let hours is equals to 0. So we have seconds, minutes, and hours all equal to 0. Also, we'll have another variable. You'll see why we are using this later on. We'll initialize this to null and let the status, basically if the stopwatch is running or not. Let the stopwatch by default be stopped. Okay, so for there should be a tick function. So every second we have to call a function that does all this logic. So we'll write that function first. So function, let's call it stopwatch. We need no arguments or parameters over there rather. And every time this function is called, we want the seconds to be incremented. And then we'll check if seconds has reached 60. Notice that I'm using the strict equality operator. If the second has reached 60, then we'll do seconds is equals to 0. And then we'll increment the minutes. Seconds, if second has reached 60, we'll reset the seconds value, increment the minutes value. We'll check if minutes has reached 60. If it has, then we'll do minutes equals to 0, and then we'll increment the hours. After all of this, we have to display this these values after we have incremented that. So we'll go and get the element, this element, the display element, and we'll change the value inside this. To do that, we say document dot get element by ID. The ID that we provided over here is display. So we have got that element, the display element, and dot inner HTML like before. We'll use a template string again. We'll pass the hours, colon minutes, colon seconds. Okay, so this should be working fine after this. But there is no function that is actually calling this this function every second. So we'll write another function to call this function every 1 second. So function start stop. In this function, if the stopwatch is already stopped, so if the stopwatch is already stopped, then we have to start the stopwatch. So now this interval comes into picture. I'll tell you what that is. Interval is equals to set interval, and we'll pass a function over here, and then we want this function to be called every 1 second. But since we have already written a function over here, we don't have to rewrite it. We'll just have to pass in the reference. So stopwatch. So set interval returns an ID of that interval to this variable. We need this variable to stop the stopwatch to clear the interval. That's why I had taken this interval variable. So after every 1000 milliseconds, the stopwatch function will be called and all of this stuff will happen. And then when we want to stop the stopwatch, we also have to change some stuff when we start the stopwatch. We have to change the button. So document dot get element by ID. We have to change this button start stop. We want to change this text to stop. So document dot get element by ID start stop. That was the ID, I think. Yeah, start stop. Dot inner HTML is equals to stop. So now we have changed the text, and after this we have to change the status to started. If the button is clicked and then the stopwatch is already stopped, we have to start the stopwatch and change the value of the button to stop. And if the stopwatch was not started, or rather if it was started, we have to stop the stopwatch. So status is equals to, if the stopwatch was running and the user clicks on the button, in that case we have to clear the interval. Now we are stopping this set interval function using the ID given by the set interval function itself. So now that we have cleared the interval, we have to change this back to start. We can just copy that. Okay. So we'll change this to start, and then the status will be stopped again. Okay, this should work. We'll look at the reset button soon, but we have to call this function on click. So to call that function on click, we have to do on click is equals to start stop. We're calling that
Hello?
function. Yes.
Somebody
Hello?
is asking why there is 3 equal symbols in the code.
I think you missed the presentation part. Okay, I'll explain it again. So just double equals basically does not compare the data type of the values, and triple equals compares the data type as well as the values. Let me show you an example. So if let's just say 60 is equals to double equals to 60. The right side is a string and the left side is a number, but JavaScript will still give it as true because it is ignoring the data types. But if we use 60 triple equals to 60, this gives us false. This is what was expected because 60 as a string should not be equal to 60 as an integer. The reason I used it in the program itself is because this is more secure than the double equality operator. That's all. I hope that doubt's been cleared. Now we are calling the function, so let's test it out. It doesn't work. Awesome. We have linked. We are calling the start stop function as well. Did we not start the server?
Hello, another doubt is there.
Huh? Not start.
What does clear interval and set time interval do?
Okay, so clear interval will stop the interval. This set interval function will continuously call stopwatch after every 1000 milliseconds. The clear interval function will stop this behavior of set interval. The set interval is returning an ID for that interval. Is that clear?
Yes, I think yes.
Okay, let me just see. I have a reference.
Yes, I think.
Okay, let's try adding the on-click event in the JavaScript itself. So document dot get element by ID start stop dot add event listener. The event listener is click. So on click we have to call the function start stop. Status is stopped. Okay, fine. The files are also linked.
And another doubt, somebody is asking, shouldn't start stop have status as its argument?
No, we are directly having a status as a global function over here, so a global variable over here, so we can directly get the current status of the stopwatch. There's some mistake that I've done. I'm not able to find it. Let's just clear this for now and see if just this works. Okay, so that works. We'll have to implement the stopped feature. Let's change the status to be Boolean. So false will tell us that the stopwatch is not currently running. So if not status, if the stopwatch is not running, then execute this code, else execute this code. Okay, now it does work. I think there was some error with my strings. So start will start the stopwatch and stop will stop the stopwatch. Let's try it again. Let's speed up the stopwatch by a little bit. Let's change this to every 1/10 of a second. Okay, so after 60, our minutes value has been incremented. Let's see if the hours also changes. Let's make it even faster. Every 1 millisecond equals to a second. I'll drink some water until then. Okay, so the hours value is also incrementing. Now let's look at the reset function. In the reset function, we have to reset all the values to 0 and change, if the clock is already running, we have to change this inner HTML to stop or start rather. So let's write a function for reset. Function reset. If the status was running, then we have to clear interval. Okay. If the stopwatch was running, then we have cleared the interval. So basically stopping the stopwatch, and we change the seconds to 0. We change the minutes to 0, and we also change the hours to 0. Another important thing about JavaScript is that you can choose to ignore these semicolons. JavaScript will not mind. So if you don't write the semicolons as well, it's fine. I have an extension called Prettier. It inserts it automatically for me. Okay, after we have done all of this, we have to change the timer. Basically this. So we'll change the timer back to 000, and finally we'll change the button to start again if it's in stop. So that's the reset function. So start. stop, and reset. Okay, we didn't call the reset function up. So let's call the reset function. Document.getElement by ID, reset. I think that was the ID. ID is reset. And on click, we have to call the reset function. I think we have to move this down here. Okay. Now, if I start, stop, reset. And if it's already running, let's say start. And now if I reset, it will change this stop button to start and also reset all the values. So this was the second project. You can implement milliseconds if you are like change this to 1 and include a dot after the second spot. Let's move on to the third one, probably the most interesting of all the three, that is the random color generator. So again, we'll have an index.html and index.js. In the index.html, we'll have the boilerplate code, and we'll also link the index file with the index.js file with the index.html file. Okay. Again, we'll not insert anything over here in the body, we'll directly insert it from the JavaScript file. I'll restart the server for this new project. Okay, now we have an empty canvas again. So let's start coding. So basically, how the random color generator will work is, we'll have hex values, hex color codes. A hex color code is basically in this format: hash FFFFFF. So this is white color. We have 6 hexadecimal values prefixed with an hash. So we have to generate the string randomly, and we have to change the color of the page according to the randomly generated string. So again, let's get the body. So we have a reference to the body now. Let's also have a h1 to show what the color code is. The color code in the beginning will be all white, so h1.innerHTML would be color code hash 7fs. And then we'll have a button to change the color. So const button is equals to document dot create element button. Now we have a button. We want the button to be named as change color. So button dot inner HTML is equals to change color. So now we need to add the logic to change the color. To generate the random colors, we need to choose the hexadecimal values. So let's create an array for that. 0 to 9. And then we have the alphabets A to F. Now we have 16 total values in this array. Now we have to pick 6 random values each time the change color button is clicked, generate an array, and then append it to the body. Let's do that. Let's create a function called get random color. And then let the hex value in the start be just a hash, because all the hex values start with a hash. And then we have to loop 6 times. So for let I is equals to 0, I is less than 6, plus I. So each time in the iteration, we have to append a value from the array to this hex string. So we'll do hex plus equals a random value, so letters of math.floor, math.random. Random number will be generated between 0 and 1. 0 is included, but 1 is not included. We are using floor to get the, because arrays are 0 indexed, arrays are starting from 0 index. So we are using math.floor. So math.random into the length of this array. So letters dot length. So this will give us the random colored string. Let's return this from this function. So random color is generated and returned from this function. We have to insert and append this to the body now. So we have created a button over here. We'll have to listen for click events on that button. So button dot add event listener. The event is click. So every
Can you
click we have to
range of the random?
what? Can you please repeat the question?
How to change the range of the random?
We are just multiplying it directly. That's how we are changing it. It will always give a value between 0 and 1. Multiply it with 100, it will give a values between 0 and 99.
Have to insert and append this to the body.
Okay. And another doubt.
We have created a button over here.
Can you explain the line 14 again?
Click events on that button.
Line 14, this one? Okay. We are running the for loop 6 times because we need 6 random elements from this array. Each time in the loop, we are appending a random element from this array. This whole part is basically us choosing a random element from this array. So math.floor, floor will give us the, if the value generated from this function over here is, let's say 1.9, math.floor will give us 1 instead of 2. Math.round would have given us 2. So math.floor gives us the lower integer value. Math.random is generating a value between 0 and 1. So 0 and 1, any random value multiplied by 16. This will give us from 0 to 15, all the values from 0 to 15. So 0 to 15 are exactly the index values of our letters array. So we are getting one random value each time from this iteration. I hope that's clear. Okay, so let's get this hex value by calling the function get random color. So here we are calling the function. This will do all this generation part and give us the random color that is being generated. Now we have to change the color of our body over here. To do that, let's say body dot style dot background color. Equals to this hex value that we just generated. After this, we also have to show the hex value to the user. So h1 dot inner HTML is equals to a template string. Color code would be this hex value. I think that's it, but we have still not appended the button or the h1. So let's do that. Body dot append child h1 and body dot append child the button. Now the background is completely white. If we press change color, the background color will change and it will also give us the value of the background color. The reason why we didn't use math.round over here is because it will give us up till 16. So it will give us undefined in some cases. Like this, we are getting undefined if we use round. So we'll change back to floor. This will give us 0 to 15 exactly. And that's how we create a random color generator. Those are all the 3 projects. I'll be sharing all the 3 projects through GitHub in the WhatsApp group. Let's continue with the asynchronous JavaScript, which is the final part of this workshop, and it's the most interesting part as well. I think we had left after event loop. So asynchronous JavaScript. Like I said before, the loading of JavaScript file might take longer, so we do it on a different thread. That's all asynchronous is. Let's look at what callbacks are before actually going through asynchronous code. Let's say we have a function called A that receives a function B. It does something. Let's just log something. Say downloaded, downloading rather. And once the download is complete, let's call B. We have not defined B yet. So basically, B here is the callback function. A is doing something, and once that task is completed, it's calling the function B. So let's try and execute this. We'll call A with a function, with an anonymous function. I'm passing the anonymous function. And the anonymous function will, let's say after download, we are installing it. This is a callback. First, it calls A, executes, does a task, then it calls B. Once the task is complete, it calls B and then it installs. So B over here is that is a parameter that is being passed. This function is called as a callback function. This is a prerequisite for asynchronous JavaScript. Okay, so functions running in parallel with other functions are called asynchronous functions. An example, the best example probably would be set timeout or set interval that we just witnessed. There are multiple ways to handle asynchronous code. The first way is to write promises. Promises are a standard way to write asynchronous code. A promise guarantees a result in the future. It's much like a promise in real life. A promise can either be kept or it can be broken. So if it is kept in JavaScript terms, it is called promise resolved, or if it is broken, it's called promise rejected. So and by the way, you'll probably never write promises on your own. You'll just be using these promises. I'll show you both how to write as well as how to use them. So let's write a function called A. This has a status. Let's assume the status true basically means the task that A was supposed to do is happening successfully or has happened successfully. We'll return a new promise. Promise is a class. This takes an argument of a function. There will be two more parameters here. One of them is resolved and one of them is rejected. Resolved is when the promise has been successfully executed. Reject is when there was an error. So let's say if status is true, then we'll resolve. We are not returning anything. We are just calling the resolve function. Else, we'll reject. Since this is currently hard-coded to true, this promise will always be resolved. So basically what a promise does is, let's log this. We'll call the function A, let it do its thing. We'll then say dot then. So dot then basically executes or gets the promise object that we pass over here. Let's pass success from the resolve section and failed from the reject section. So complete the function A and dot then. So basically after the execution of A, either successfully or unsuccessfully, then we'll get an object. Let's log that object. This syntax basically means execute the function A and then get the result and console log the result. So we get the success as the result over here. This is giving promises pending because we are also console logging the promise that was sent by A. We can basically remove this. And now we'll get only success. But you'll notice that if I change this to false, basically there was an error in the execution of the code of A, then we'll catch an error over here. To handle this error, we have to add a dot catch, and this will catch the error object. And let's log this object. If the function was successfully executed, we'll go to the then clause. If the function failed, then we'll go to the catch clause. So in this case, since the status is false, by the way, this is a bad habit. Without writing let, var, or const, this is a global variable. We should never write global variables. Let's make it let scoped. and now we can see that the catch block has given the output as failed. This is promises, but sometimes there are objects that will return promises after promises. So basically dot then and dot then and dot then and so on. In this case, there is another method to handle asynchronous JavaScript. That is the final part of this workshop, the async await part. It is an alternative approach to deal with asynchronous code. It makes promises easier to write when there are multiple callbacks. The keyword async is used to define an asynchronous function, and an asynchronous function by default returns a promise. The keyword await is used to wait for an asynchronous function to complete. And the keyword await cannot be used without the function being an asynchronous function. So let's look at that example. Let's create a function async. Okay, so this is an asynchronous function A. Actually, we don't have to even do this. We'll just use the previous function over here with the status. Okay. So now we have a function that is returning a promise. We have to deal with that promise. So let this function be called B, but we want this function to be an async function. So this function B will wait for A to complete. This is happening outside the normal JavaScript execution loop. So to wait for the result of this object, let's change this to true again. And let's say const result is equals to await the successful execution of A. So basically await until A is completed successfully or unsuccessfully, and then pass the result to the result object, and then let's log the result. Let's call the function B for the whole thing to be executed. And now we expect the result as success. And finally, there is no dot catch over here to catch the errors. So basically, if this was false, we'd get a real error. To handle that, we need to use a try catch block. Try, and then a catch. Okay, since the status is false over here, the promise is getting rejected and it's sending failed as the parameter. So if I run this now, we'll get failed as the output. This is a much more cleaner way to write than the continuous callbacks in case of promises. I think that's all from my side. I thank you to Kiran Tangod sir for giving me an opportunity to share my knowledge of JavaScript with the students. Thank you so much. I think that's all from my side. Thank you to Kiran Tangod sir for giving me an opportunity to share my knowledge of JavaScript with the students. Thank you so much.
Another doubt is there. Can we make use of the sensible function name?
Can we make use of the
Sensible function names?
yeah, sure, we can.
Okay. Can we?
Functions name could be anything. I just used simple names for better understanding.
He came forward for giving this talk on JavaScript basics, and I really appreciate the efforts put in by him for continuously giving a lecture for 1.5 hours on all the basics of a particular language, and also dealing with 2 to 3 projects which people can apply their knowledge and understand their learnings in this workshop is really commendable at this particular point in time. Why I'm giving these remarks is basically because if you go for any of the professional code snippets teachers or professional videos that you get on YouTube. You can see the YouTube videos are for only 10 minutes or 11 or maximum of 15 to 20 minutes. Nobody teaches you for such a long time wherein the person is putting 1.5 hours of time for teaching some good techniques, tricks, and some good projects on which you people can work, and you can learn some good new things, so that it will be an addition to your resume, as well as it will be one good language which you can learn, which is presently in demand in the market. So from my side and from my department side, as well as from ACM student chapter side, I thank Shreehari for giving such a good lecture on JavaScript. And I want a few more students or many more students from our department and our college to come forward for such type of workshops in future. Whatever are the hurdles, whatever difficulties you face during conduction of such type of events, you will have to just ignore and go ahead with your good work that you want to do, and don't just go back and relax that you have learned something very new, and that is the end of it, because every day you have some new thing to learn. Okay, so all the best for all the people who have attended, and happy learning in future. Thank you.